Okay, so let's take a look at solving rational equations. So how do we solve an equation that involves rational functions? In this case, we have n squared minus 9n minus 10 over n plus 1, so a rational function, divided by n minus 10 over n plus 3, so another rational function, equaling negative n plus 5 divided by 3, which is a linear function. So first thing we need to do is we're going to convert this from a division to a multiplication. Make life a little simpler on us. So n squared minus 9n minus 10 over n plus 1 times the reciprocal of this rational function, n plus 3 over n minus 10, still equal to this linear function, n plus 5 divided by 3. Now, the next step we want to do is we want to factor this n squared minus 9n minus 10 and see if we can cancel out some of these factors to make our job a little simpler. So I'm going to take this n squared minus 9n minus 10, remembering that it's in the form ax squared plus bx plus c. And I'm going to take my a value, this 1, multiply it by my c value, so I get negative 10. I'm going to factor it. Remember, since this is a negative 9, my larger factor is going to be negative. So 1, negative 10, 2, negative 5. And I'm going to look to see which factor pair adds up to negative 9. And that's my 1, negative 10. So I can rewrite this as n squared minus 10n plus n minus 10. And this is the same quadratic as this because negative 10n plus n is negative 9n. Now, I'm going to bracket or put parentheses around my first two terms, my second two terms, and factor by grouping. If I look at my first term, my first pair, n squared minus 10n, I can factor out an n. So I have n. And this leaves me n minus 10 plus. The second pair, my greatest common factor is a 1. So I'm going to write it out here just so we can visualize it. Leaving n minus 10. So we can see our common expressions, n minus 10 and n minus 10. So if I factor those out, I have n minus 10 times n plus 1. And these two, n minus 10, n plus 1, are our factors of n squared minus 9n minus 10. So come over here, and let's rewrite our equation. So now I have n minus 10, n plus 1 over n plus 1 times n plus 3 over n minus 10, still equal to negative n plus 5 divided by 3. So before I go any further, I need to take a look at these two denominators. So remember, anytime your denominator is equal to 0, your function is undefined at that value because we have division by 0 going on. So whatever solution I come up with, I've got to take these into account. So n cannot equal negative 1 because that would make this denominator 0, nor can it equal 10 because it would make this denominator 0. So whatever solutions I come up with, they cannot be negative 1 or 10. So now, looking at this, I have a series of factors that I can cancel out. I have this negative 1, or n plus 1 here, n plus 1, so common factor in the numerator and denominator, so cancel those out. And then I have this n minus 10 and this n minus 10. Again, common factor in the denominator and the numerator, cancel those out. So rewriting this with our canceled terms gone, I can write this as n plus 3 equals negative n plus 5 divided by 3. Now to solve, I simply multiply both sides by 3 to get rid of that denominator. Remember to distribute because we're multiplying this entire side by 3. So I get 3n plus 9 equals negative n plus 5. So add n to both sides. 4n plus 9 equals 5. subtract 9 from both sides, 4n equals -4. Divide both sides by 4, and I get n equals -1. Now, look back. I said up here, n cannot equal -1 because that would make this denominator in the original equation equal to 0, so we'd have division by 0 and then an undefined function. So this n minus 1 solution here is an extraneous solution. And since it's the only solution we came up with, this equation has no solution.